Hi everyone, so we are back into our gate crash course on signal and system, right? So we started network theory and we are doing signal and system. So this is going to be a day 2 session, right? So again I will start giving you a kind of quick revision on this signal and system, right? So we started with the first. I think many people have watched, around 70 to 78 people have watched. Okay, and I hope many of you might have, you know, got some new insight about signal and system. So now in this session, what I'm going to talk about is this is going to be lecture number 2, right? And this is day 2, you can say. Okay, day 2. Now we have a couple of months left. Okay, so till within these 10 days you can finish entire syllabus, and then you can start PYQ from December 1 along with me, right? As I am going to start the PYQ series from December 1, right? Okay, so let us begin the session here, guys. Last time we have discussed about energy, power, signal. Okay, so many concepts we have discussed, and I also told you that where we have to use those formulas, right? Like okay, where we have to use limiting formula and where we don't have to use limiting formula, right? See, as far as the signal is periodic signal, so you don't have to worry about those limit. Limiting t tending to infinity and then integrating and finding the energy or power, right? As long as the power, as long as the signal is periodic, okay, you can directly find the energy over a period and then divide by the time period. That's it. Okay, so in this session I'm going to talk about the operations on signals. Operations on signals, right? So let me minimize myself because I think I'm looking very big today, right? I'm not big that much, but yeah, fine. So let's begin here. So in this session, what I'm supposed to talk here is I'll talk about operations on signals. So what are the operations that we can perform on signal, right? That is very important. Operations on signal. Okay, I'm not going to give you much detail here, but I'll just give you the brief idea behind this. Okay, the brief idea you can see. Okay, so you know that we can add two signals, right? There are many operations what you can perform on signals. Suppose two signals are given, so you can add them. How to add two signals? You have to always remember that point wise sum we always perform, right? So there are few things that you have to understand, right? So in addition to some differences, or you can say product, right? So you can always do what are the things that you can do with the signal. You can add two signals, you can say sum, right? Some you can perform, okay, and or you can also do differences, like you can find the difference, right? And how can you multiply two signals? So you can also perform product, right? Products. So these things are done in point wise, point wise, you can say point wise. Point wise, what is the meaning of point wise? Suppose two signals are given, just I'm giving you the example. Okay, we don't know what kind of signal is this, but yeah, suppose this is a signal, okay, and some signal is given here, you can say like this, some kind of a signal is given, right? Suppose this is x1t and this is x2t. Okay, now you have to multiply these two signals, right? If you have to multiply these two signals, okay, you can say multiply. So you have to multiply, or you have to take the product point wise. How point wise? You start from minus infinity to 0 here, minus infinity to 0. You see here this signal is 0 completely with the you can say for t less than 0, this signal is completely 0. So if you multiply anything 0 with non-zero, okay, so resultant is going to be what? Resultant will be 0 only, right? So you see point wise we are multiplying, right? You see from here to here we are multiplying first, and then we are multiplying from here to here, right? You can say, so the same signal is going to appear here, you can say the same signal is going to appear. So these are the operations we always perform. So you should know how to add two signals, how to multiply two signals, and how to subtract two signals, right? So you can do that exercise by yourself, right? So what we are going to talk about is, in addition to, you can say, point wise sum, differences, or product, the commonly used operations on signals are what? You can say basically we are going to transform amplitude or time, right? So transformation of amplitude or time, right? Okay, that we are going to do. So how to transform, how to change, you can say how to scale Okay, transformation is nothing but what? Scaling, you can say, right? How to change amplitude of a signal, how to change, time axis, right? How to shift a signal from, you can say, left or right, okay, and so on and so forth. So these operations are basic, okay, in addition to, you can say, sum, differences and product, right? So transformation of amplitude and time, you can say that transformation of amplitude and time. So we are going to play with amplitude as well as the time. That's it. Okay. So that will become very simple thing that you can always remember. So what is the meaning of here? We will talk about scaling, right? So there will be two kind of scaling. One is amplitude scaling. So time is same always, right? If you're changing, amplitude, I think many of you might have done like, you might have shifted function up and down, right? So any function is given, you can shift by adding some, some dc or something, okay. So amplitude shifting can be done by adding some dc, okay, or by adding some constant to the signal, okay. Or amplitude scaling can be done just by multiplying the signal by some constant, okay, scalar constant. So the very first is nothing but amplitude scaling, right? Amplitude scaling, okay, amplitude scaling. So suppose xt is given, so you can scale it by c. So what will happen here, that c times xt, right? Simple, that's it, okay. Just you have to multiply by some scalar constant. Here time is same here, okay. Time is not changing, remember, only your amplitude is changing, okay, because of this time amplitude scaling, right? So if you are going to multiply xt by c, okay, c is going to get multiplied with all the signal values, right? Okay, to generate c times xt. And if you want to shift, okay, I think in analog circuit also you might have seen, suppose I want to shift my AC signal to at certain DC, right? So we are adding DC, right? So if you add DC plus AC, that is nothing but a clamping circuit, right? Clamper, just like amplitude shift, okay. You take any xt signal, you can add, some constant k, so that is going to shift, right? Okay, up or down depending upon the value of k, right? Okay, so these are the two things that you have to remember, okay. So here amplitude shifting might be there, amplitude shift, okay. Suppose xt is there, so if you add here plus k, you can say, right? So it will become k times k plus xt, right? So this is shifted version of, xt, right? So this is called amplitude axis, okay, amplitude shift, sorry, okay. So you have to remember always there will be two axes. One is amplitude is axis and one is time axis. So this is gonna be time axis, this is amplitude axis. So whatever modification you are doing, like you are scaling amplitude, so everything is gonna happen here on the y-axis. And okay, I hope this makes sense to all, right? Fine. See, you are not transforming here time or something. You're just transforming amplitude, right? So keep in mind time. This t is quite okay. You can say same only, right? When you do amplitude scaling, okay? Fine. तो टाइम स्केलिंग, टाइम शिफ्टिंग क्या होता है? अब टाइम शिफ्टिंग की अगर बात करते हैं, तो टाइम शिफ्टिंग में इधर यू कैन डिले द सिग्नल और एडवांस द सिग्नल, ओके. दैट डिपेंड्स अपॉन the amount of shift, right? Whether it is positive or negative, right? So suppose you have got see, I'm going to talk about time shift. Time shift, it's a very simple concept, time shift, okay. Now why do we want to yeah, hi Tomby, yes, hi, good afternoon, right? So why do we want to shift? Everybody knows, right? जैसा कि मेरा क्लास 3 PM से है, ठीक है. अब I have to delay, okay, my class, okay. So you can say that I'm just going to, so delay or advance, you can take any real life examples also. जैसे आप ट्रांसमिशन लाइन ले लो, right? You are giving some signal, that signal is not reaching at the end, okay, at the load end, you can say, right? तो क्या होगा, वहां पर डिले ऑकर हो रहा है, signal is has got delayed, right, by some delay of the transmission line, right? L by V, okay? ऐसा नहीं होता कि as soon as you apply the signal, so you are going to get at the end of the load, right? Okay, तो आप समझ सकते हो कि टाइम शिफ्ट, टाइम डिले, है ना, ये बहुत इंपॉर्टेंट है सिग्नल प्रोसेसिंग में, ठीक है. तो टाइम शिफ्टिंग का मतलब क्या होता है? व्हाट इज द मीनिंग ऑफ टाइम शिफ्ट, राइट? So time shift basically what it does is like xt will be given. Okay, so it is not going to change its shape. First of all, you have to remember when you do time shift, right? So no change in shape. Okay, no change in shape of the signal. Whatever signal it will be there, that will be always the same, you can say, right? Suppose we have got a signal here, right, like this, you can say, kind of signal, you know 0 to, you can say, capital T. This is a xt here, you can say, right? And suppose I want to shift this signal, you can say that I just want to do xt minus capital T, right? Xt minus capital T. So what we will do here is you just take t minus capital T, right, and equate with 0 here and find out small t value, that is t. So just add this t, just add this t to each time instant. So you will get here what? You're going to get the shape will be same, right? But now your signal has got shifted from 0 to t to 2t, right? And this shifting has been done in the right side. Okay, so it is a right shift, you can say that, right shifting. Okay, so how we have to shift? Always remember xt will be given. क्या दिया रहेगा? xt will be given and xt will be given, always remember. And then what you can do, if you want to find t minus capital T, मतलब right shift होगा, ठीक है? t plus capital T अगर दिया है, या कि t plus t not whatever, okay, so as long as your amount of shift is negative, right? Okay, how you will come to know that? देखो, suppose xt is given, right, and you can do x time, shifting like this, plus minus t naught, right? Plus minus t naught. Okay, now you see here, suppose you take t plus t naught, okay, equal to 0, so t equal to minus t naught. If this is negative, मतलब left shifting होगा, left shifting, okay, left shifting will be there. Okay, or you can say that it is nothing but an advanced one, advanced. And suppose t minus t naught equal to 0, okay, so t equal to what? T naught, which is greater than 0, you can say. So here right shift you have to perform. So it's a, so what you have to do always is signal will be same, you just draw the signal as it is, only time axis can change, right? Time axis, okay, it can shift to right or left, okay, that you have to remember. And remember this time shift, okay, if you talk about in future, you will talk about frequency domain, right? Frequency domain, you will go from time domain to frequency domain. So this time shift correspond to what? This time shift correspond to phase change. Always remember, guys, this is very important concept that I'm telling you. This time shift correspond to phase change. Okay, if in the time axis, or you can say if in the signal, if you have shifted your signal left or right, in the frequency domain you're going to get some phase change, right? Okay, phase change. So time shift is equal to phase shift, you can say, or phase change, right? Always remember these, this is very important correspondence. Okay, ये लोग नहीं जानते हैं, बस प्रॉपर्टी याद कर, आपको पता होना चाहिए कहीं भी, if anywhere time shift is there, right, so certainly you're going to get phase change in frequency domain, right? तो ये याद रखना, ठीक है, परफेक्ट. सो ये राइट शिफ्ट हो जाता है, ठीक है. You can take any signal and you can play with. Okay, that is what the main thing is. Then we talk about what? Then we talk about time scaling. Time scaling क्या है? देखो, time scaling. Okay, in time scaling nothing is gonna shift. Okay, like left and right shift will not happen, right? Time scaling में क्या होगा? देखो, suppose xt is given. Given क्या है यहाँ पर है? xt. And suppose you want to find x alpha t. Now this alpha can have two values, right? See, this alpha can be alpha can, mod of alpha you can say is greater than 1 and mod of alpha is less than 1, you can say, right? Okay, if mod of alpha is greater than 1, you can say, right? So क्या होगा? If mod of alpha is greater than 1, right, or you can say that okay, so it is going to introduce compression, right? Signal will compression, right? If alpha is less than 1, so it will expand the signal. Expansion will happen, right? Okay, understood. And if alpha can be -1, if -1, right, so इसको हम लोग बोलते हैं टाइम रिवर्सल. क्या बोलेंगे? टाइम रिवर्सल. Simply टाइम के मतलब बाई एक्सिस के अबाउट रिवर्स करना है, दैट्स इट. ओके, तो इन केस ऑफ टाइम स्केलिंग शिफ्टिंग विल नॉट हैपन, कंप्रेशन ऑफ द सिग्नल विल हैपन. कैसे हो रहा है देखो, आई एम जस्ट गोइंग टू टेल यू, राइट. तो कभी भी मान लो xt आपका यहाँ पर दिया हुआ है, सपोज दिस इज गोइंग टू बी अ xt सिग्नल, राइट, काइंड ऑफ xt यू कैन से माइनस टी नॉट से लेके टी नॉट इज अ you know kind of xt given, right, xt. Now you have to find x alpha t. Okay, forget about alpha whether it is greater or smaller. So what you have to do always is you have to take this alpha and divide by these guys. Okay, so the new time axis, you know, this is the new time axis, you can say new time axis, right. Just write time t. Okay, and what you can do here is you can do always just write here minus t naught, and this is t naught only, and then divide by alpha. The signal shape is going to be same only, right? I mean, okay, so you see here it might get compressed. Okay, compression हो सकता है या कि expansion हो सकता है, right? That you have to keep in mind always, right? So what you have to do always is जब भी scaling करना है, you take the signal, divide those time instant by alpha, right? That's it. Okay, let me take one simple example and show you. Suppose you have got a signal of this kind. Okay, so this is going to be a signal, you can say minus 2 to 2, right, xt. So we don't know what kind of signal is this. Okay? In future you will come to know this is triangular function or triangular signal, right. So if you're going to scale, suppose you have to find x to t, so recognize that this alpha is greater than 1. Certainly what will happen here is that compression will happen. Kaise dekho, you see here what you have to do, then you have to just divide these time instant, you know, just you can say that 2 times t you have to find, right, 2 times t. So what you just place in place of this t 2 times t, right. So here I am putting what, 2 equal to 2t, what is t, 1. Here I am putting what, minus 2 equal to 2t, so t equal to minus 1. So instead of equating these things, right, like 2 equal to 2t, 2 equal to or minus 2 equal to 2t, what you can do, you just divide by alpha, okay, directly. So your time axis will become what, your time axis will become now from minus 1 to 1. You see here your signal got compressed, right. Earlier this width was, you can say, 4, now it has become 2, right. So why this is happening, because of time scaling, you can say, right. So simple concept what I told you here is आपको क्या करना है, by alpha you just divide all the time instant, or what you can do, all the time instant can be equated with this 2t, right. Okay, and then find out t value, right. That is what I can suggest. Okay, so that will not give make like you will never make any kind of mistake over there, right. Fine. So time axis is done, right, and as I told you, reflection or folding is nothing but when alpha is equal to minus 1. So alpha equal to minus 1 means what, suppose xt is given, so suppose alpha is minus 1, so you can say that it becomes x of minus t. इसको हम लोग बोलते हैं क्या, folding or can say that reflection about bi-axis, right, or amplitude axis. So reflection or folding is just a scaling operation with alpha equal to minus 1. Remember, okay, this is just a scaling operation, right. And what does it do, it creates the folded signal f of, you can say, x of minus t as a mirror image of xt, right. So x of minus t is going to be what, this guy is nothing but a mirror image of x. What you can do here is, suppose this is a signal xt, minus 1 to 1, it has symmetric limit, you can say minus 1 to 1, right. So if you are going to find what is x of minus t, so same, why, because just reversal will happen, okay. So why xt equal to x of minus t is there, because this guy is even, this is even signal, okay, you can say even signal, right. So whenever mirror image is going to be same here, signal and the mirror image of the signal is same, it means the signal is even signal, okay. So ये सब बहुत simple चीजें हैं, आपको याद रखना है. But one of the very important thing that I want to highlight here is always remember, okay, shifting और folding, क्या ये याद रखना, ये important नोट है for gate examination, right? For uh, you know, for gate exam, जब भी आप गेट एग्जाम दोगे और क्वेश्चंस आएंगे, ओके, तो ये बहुत इंपॉर्टेंट कॉन्सेप्ट मैं आपको बता रहा हूँ, ठीक है, कि दिस नोट इज वेरी इंपॉर्टेंट, ओके. Note that the shifting or folding of a signal will not change the area or energy. Yeah, shifting or folding of a signal. Okay, do not change in area or energy. Right? Remember, this is very important concept, right? In turn, you can say power as well, right? Okay, so shifting you do or folding you do, your energy is gonna be same. What is the meaning of that? Suppose, let me give you the example here. Suppose xt has the energy E. If someone is going to ask you what is the energy of xt minus t naught, same. No change will happen in the energy, right? So this is very important concept that you have to always keep in mind, right? Shifting or folding of a signal does not or do not change in area or energy of a signal, right? Please remember this, okay? But time scaling will reduce both area and the energy by mod of alpha. Suppose ऐसा है, ठीक है, this is note number 1. The note number 2 you can remember is time scaling will affect area और energy. कैसे अफेक्ट करेगा, देखो, suppose xt has the energy E. If someone is going to ask you what is x of alpha t, so you will say that, sir, energy is going to be what? Mod of alpha. Right? Why mod of alpha? This alpha can be negative as well, right? Alpha can be negative, and as we know that reflection, or you can say that the folding, right, does not affect the energy or area, right? So this is very important relations that is very useful for during the gate examination, right? Okay, remember that while solving the question. So you can solve questions very quickly then, right? Okay, so these are the information that I told you. Now the operation will happen in combination also, right? You can say combined operation. If I talk about combined operation, like shifting as well as scaling, okay, so now I'll talk about combined operations. Combined operations means what? Here scaling as well as shifting, okay, both will be there. Understood? Scaling as well as shifting, you can say that, suppose xt is given signal, so x of alpha t plus minus beta, you can say that. So here what is there, by alpha it is going to get scaled, time is going to get scaled, right? In this they can also perform what? Amplitude scaling, right? So they can give all the combined you can say operations. So which operation you have to perform first, that is very important to keep in mind, because many people make mistake here as well. Okay, the xt is given, and suppose you have to find x alpha t plus minus beta, you can say here it is nothing but x alpha t plus beta and x alpha t minus beta. Okay, so what are the operation that you have to perform, right? First, which operation you have to perform first, right? So I will suggest here, always remember, this is very important to keep in mind, right? So what we are assuming here is that you can assume that alpha is greater than 1 and beta is greater than 1, right? So alpha is greater than 1. If alpha is greater than 1 means compression will happen, right? And then okay, so so I'm just going to tell you here the important method, right? Okay, follow this method only, right? Suppose you have got xt, it is given, and you have to find what x alpha t minus beta, you can say, right? So first of all, what you have to do in this, the step number one is take alpha t equal to p. You just consider alpha t equal to p, right? So it is nothing but p minus beta. Simply you shift your entire signal xt by beta, right? What you can do, shift your original signal xt by beta. Then what you have to do, then once you have shifted, then you can scale it by what, alpha. Okay, then you can scale it by alpha t, right? So I think this is clear. So your xt will become xp, then xt will become xp. Okay, then what you can do, you can shift it by beta, then scale. So what is this? First shift, okay, what we are doing is first shifting and then time scaling, okay? So this is one of the method that you have to follow, right? Remember, whenever there is a combined effort, right, combined operation is going to happen, so first you have to shift the signal, then scale it by something, right, by the amount which is given in the question, right? So this is very important to keep in mind. Okay, so yeah, so I think this is clear for all. Okay, so we can take one example also if you want. Suppose we have got an example, right? Let me take one simple example. So this combined one, suppose we have got a signal like this. Okay, this minus 1 1, right? This is x of t, you can say. Okay, you can fix 0 anywhere, right? Wherever 0 exists, you can say there is a 0. I'm not showing, right? That is not important for us, right? Whenever we play with the time, right, time axis, you know, when we shift or scaling, we don't have to worry about that you know, amplitude or something, right? So what we have to find in this question is you know, xt is given here, right? So what we have to do here is we have to get what, suppose yeah, suppose we have to find 2 times of x minus t by, okay, you see how fast I will be doing, right? Minus t plus you can say that 2 by 3, right? We have to find this. See here, time scaling is there, right? Time shifting is there, as well as amplitude scaling is also has been done. Here 3 operations are combined. Okay, 3 operations are combined, and now how quickly you can perform the same, right? So let me tell you here. First of all, don't focus on time, you know, like, you know, amplitude scaling and all. Just forget about that first. And later you can do, no problem, right? First of all, what you can do here is you can just shift by what? Just consider this guy is nothing but what, p, right? This guy is nothing but p. So you shift this entire signal by you know, entire signal by what, minus 2 by 3, right? Minus 2 by 3, because you see p plus 2 by 3 is equal to 0, p equal to minus 2 by 3. It means you have to shift this guy to the left by minus. So here you can add, you know, like, sorry, addition means it is already negative, so you can say that minus 2 by 3 and minus 2 by 3, right? So your time axis will become what, you can say that this is nothing but minus 5 by 2, yes, if I'm not wrong, right? And this will be 3 minus 2 by 1, so this is nothing but 3 minus 2 by 1, which is 1 by 3 only, right? Yeah, your signal is here now, right? See, your signal is here between minus 5 by 2 to 1 by 3. It has got shifted, right? It has got shifted to the left. Okay, now what you have to do now is this is very important. Yes, so now what you have to do, the next operation should be what, next is you can time scale, right? That's it. Okay, so next is, this is the times, you can say shifting, first shifting, okay, then scaling, right? So if you scale now, then what is scale, time scaling, okay, time scaling. So what you can do, there is a minus 1 by 3, so just divide this by minus 1 by 3 and minus 1 by 3, right? Okay, so minus 1 by 3 you are dividing, so this will become plus, right? this 3 goes up, so it becomes, let me draw here. You can see that this become, this become, what, 3 by, okay, so this become -1. Your signal is here, right? This guy is here, okay. Now this guy will become to this, okay. You can see that 15 by 2, 15 by 2. Okay, so I think this was correct. -1, -2 by 3, right? So here 3 is the LCM, so -3 -2, yeah, it was correct, right? 15 by 2, fine. Okay, so this is how we can do here, right? It's a very simple process, okay, that you can always do, right? So now what you can do, now you can simply multiply by what? You can simply multiply by 2, it becomes 2 only, right? Because this is very simple process, okay. So what we have done here is, I think there is some sort of, yeah, okay, here I think we have done mistake, so we can correct it, right? So it should be 3, right? No problem. Okay, that's why I was thinking how it is coming, right? So it is 3, 3, 3 gone. You can say this is 5, right? So this is the answer for this question, right? You see, from here, okay, to here, what we have done. First shifting, then scaling, right? So please make sure that this is 5 by 3, right? I have written 5 by 2, but it should be 5 by 3, right? So first shifting, then scaling, okay? And then amplitude scaling, right? Okay, as long as this is 1, okay? So ये combined operation that you can always perform, right? Now we will talk about symmetry, guys. Symmetry is one of the very important concern, right? In anything you discuss, okay? If you find out the symmetry, suppose you're solving any circuit, okay? You have got a very big circuit, right? Like so many transistors are connected, okay? This side, that side, okay? And if you take the symmetry, okay? So what you can do here is you can analyze half of the circuit. The half of the circuit analysis is done, right? So always try to find symmetry, always try to exploit symmetry, in the question. If any question is given, try to find symmetry, right? Symmetry is one of the very important concept, right? Okay. So signal symmetry, basically I'll talk about signal symmetry. Signal symmetry. Okay. Signal symmetry. Okay. In case of signal symmetry, what will be there? If the signal is identical, you can say it's folded version, right? If you take xt and x of minus t, if both are same, right? Okay. What you can say that if signal is there, xt and x of minus t you calculated, both are same. So it is called even symmetric. Okay. Even symmetric, and even symmetric is also known as, you can say, mirror symmetry. Okay. Mirror symmetry about the vertical axis passing through the origin t equal to 0, right? That you have to remember always. If xt is equal to x of minus t, then it is a even symmetry, even symmetric, okay? And the mirror symmetry will be formed about, you can say, vertical axis passing through origin at t equal to 0, right? Okay. And if suppose signal and its folded version is not going to be equal, okay, like x of t is not equal to x of minus t, right? X of t is equal to minus x of minus t, that we call odd symmetric, right? So, and remember that the signal extend over what? The signal will always extend over symmetric limits about the origin, right? Whenever you are exploiting the even symmetry, okay, so situation will be like this. You see, the signal is going to extend it, signal extends over symmetric limits. So signal will be like this, you can see. The signal is going to be like this, you see. Okay, this is the situation here. Minus alpha to alpha. So you see, symmetric limits are given. Minus alpha and alpha. Okay, minus alpha and alpha. This is the symmetric limit. Whenever symmetric limits are given, you can say you can exploit symmetry, right? Okay. So at t equal to 0, you see, this side and this side both are same, right? So you can say that there is a even symmetry. This is having, you can say that xt equal to x of minus t. This will give you even symmetry. Okay. So whenever any signal, okay, you can say symmetric signals cover a symmetric duration, right? Symmetric duration means minus alpha to alpha about the origin. You have to make sure that, right? Whenever the signal is symmetry, having any sort of symmetry, so always remember if there is a -2, so there should be minus +2, right? Always try to write the symmetric in symmetric duration, ठीक है? Symmetric duration आप लिखो ज़्यादा सही रहेगा, ठीक है? और आप कोई भी वेव फॉर्म दिया है तो सबसे पहले आप symmetric duration देखा करो, right? First take a look at symmetric duration, okay? Then try to check, okay? तो यहाँ पर कुछ rules हैं that you have to remember, okay? Why I'm saying symmetric duration for even symmetry or odd symmetry? See, for even symmetric signal, okay, at two symmetric duration, right, what will happen? The signal value is gonna be same. Okay. So suppose you want to check whether this guy is symmetric or not, right? Even symmetric or not. So you see at minus alpha the value is this, you can say 1. At alpha the value is 1. So yeah, both are same, it means it is a even symmetric signal, right? So this is very important concept that I have told you. Yeah, he makes sure that there is a symmetric duration, you can say minus alpha to alpha about origin. Okay, so for even symmetric, okay, the signal value at minus alpha and alpha is going to be equal, right? ये बहुत important identification है, ठीक है? This is very important to keep in mind. See, when you will study Fourier series, ठीक है, तो आपका जो ऑब्जर्वेशन है वो काफी क्लियर रहेगा कि हाँ वेव फॉर्म दिया है, ओके, सिमेट्रिक लिमिट्स, ओके, राइट? यू कैन इजिली you can easily exploit the even symmetric or odd symmetric, right? Next, अब देखो odd की अगर बात करते हैं, next, ठीक है, odd में क्या रहेगा? You will be given you can say that minus alpha and alpha only, right? Okay, the symmetric limits only, provided this kind of situation will be there, right? You see, now there will be a symmetry about 0, right? Okay, you see here, this is the situation, right? Okay, so what you can do here is okay, this is very important to keep in mind, right? So here odd symmetry is there, right? Odd symmetry, you can say, okay, about 0, okay? You can say that x of t is equal to minus x of minus t. So odd symmetric. Okay. I hope this makes sense to all, right? So in case of even symmetric, right? Suppose the signal is even symmetric, okay? And the signal value is going to be what? At alpha equal to, at t equal to alpha and t equal to minus alpha is going to be same, right? The area of an even symmetric signal is what? Twice the area of either side of the origin, you can say. If the signal is symmetric and that too even symmetric, so you can find out the area by what? By 2 times of the any one side of the area, okay? That is very simple, okay? Just find out one side of the area, you know, after or before origin or after origin, you can say, right? And then there are 2 sides of the origin, okay? Then multiply by 2. For an odd symmetric signal, the signal value at alpha and minus alpha are equal but opposite. Remember, in this case, okay, when you can say that this guy is odd, okay, always observe, okay, always observe what? At alpha and minus alpha, right? The signal value is equal. Signal value is equal but opposite. It is one of the best identification, okay, for odd, you can say for odd signal, right? For odd symmetric signal, okay, you can see here, okay, here suppose it is 1 and here -1, so both are same, 1 and 1, but they are opposite. Suppose it is 1 and it is -2, they are not odd, they are not odd symmetric, okay? That you have to remember. These things are very important, okay? Always look at the symmetric limit, whether what kind of values are there. If values are matching, right, there is no difference, like out of 180-degree phase difference, right? So you can say that understood. So that is very important to keep in mind, okay? And if you talk about signal value at origin, so it is going to be 0 always, right? This is very important. Okay, for odd signal, the signal, you can signal value at origin is going to be 0. Okay, signal value at origin is going to be 0, right, for odd. So these are the points that you have to remember always. Okay? So I think this is clear for all. And the area of the odd symmetric signal over a symmetric limit. This is also very important point. Okay. In fact, whenever people solve integration concept, right? Integration, integration is what? Integration is nothing but area under the function, right? So whenever this is very important, if the signal is odd signal, so we always say that area under the odd signal is 0, right? Or you can say that the area for, you can say area for, okay, area for the area of an odd, the area of an odd symmetric, okay, symmetric, okay, area for odd symmetric, okay, odd symmetric signal over a symmetric limit. Actually, everywhere these subjects are taught, but these things are missing, right? Basics are missing everywhere. I've seen while solving the doubts of many students, you can say around 500 students are there nowadays. I'm solving their doubts. So, I always see they're like they are lacking, in basics, right? I mean, they are not knowing these things, okay? Just they blindly solve the question, right? So they make very big mistakes, and they also follow very unconventional approach, right? So that is what I have kind of experience at this moment for gate 2024, right? So the area of an odd symmetric signal over symmetric limit, okay, over symmetric limit, you can say minus alpha and alpha is going to be 0, right? Is always 0, always 0. From mathematics also we know that area under the function, right? Integration over the period over the function, right? And the limits are like -2 to 2, okay, f of x dx. If f of x is odd, so answer is going to be 0, right? And if f of x is even, so you can say 2 times of 0 to infinity, right? I mean 0 to 2, you can say. Okay, that everybody knows, I need not to talk, right? Fine. So what you can do here is just I'm going to write in terms of mathematics also, so that for the sake of completeness, you can say that if suppose you're performing like this, okay, suppose there is a odd symmetric, okay, so minus alpha to alpha, okay, x of odd is dt is going to be 0 because of odd symmetric. Okay, this limit should be symmetrical, okay, and suppose it is minus alpha to alpha and this guy is even symmetric, you can write this as 2 times of 0 to alpha x of t dt, right? So while calculating your calculation become very simple, right, in this case. Okay, now we can talk about combination of sum and product, right? Suppose we have got some combinations, okay, and we want to exploit what kind of symmetry is there, right? Okay, so does the sum or product of two symmetric signal have any symmetry? That is the question, right? Okay, what is the question? Does the sum or product of two symmetric signals, suppose you have got two symmetric signal and if you're adding them, right, so whether the combination will have any sort of symmetry, right? That we have to understand. Okay, so the combination, okay, combination of sum and the product of a symmetric signal are also symmetric under certain condition, right? Under certain condition, and these are very useful results for problem solving, remember. Okay, for problem solving, when you will solve the problems, right, the combination of symmetric signals, right, will come into picture, right? So combinations means what? Sum and the product of symmetric signals, right? Okay, so I'm just going to write here, just remember that suppose signal is even plus even, right? You can say, so you will get even symmetric. Okay, suppose two signals are, one is even, दूसरा भी even है, so you will get even symmetry. If you're going to multiply, okay, if you're going to multiply two even, right, even into even, you're going to get even symmetry only, even symmetry. Okay, I'm just going to write in short, right? And suppose you have got odd one, right? So suppose you are adding two odd signals, odd plus, just write like this, O plus O, you will get O, right? And then if you're multiplying, odd into odd, you will get even. This is very peculiar, right? यहाँ पर क्या आएगा? Even आएगा. Okay, so please remember this point. Now, if suppose even plus odd is there, suppose someone is going to ask you whether this signal is even or odd. In case of Fourier series, these concepts are very useful. Okay, symmetry is very important, right? If you are able to exploit the symmetry, guys, okay, in case of Fourier series, whenever we talk about Fourier series, half of the job is done. Like you don't have to calculate or compute all the Fourier coefficients, right? So you have to just focus on the part of a question, right? And you can get the answer, right? So many people, what they do is they just take the question and solve it, okay? And they don't know the theory behind that. I'm very sure, right? They will directly post in different social media like Telegrams, WhatsApp, Facebook, सब जगह question आया, लो भाई डाल देते हैं. But they don't know the theory behind that. Proper theory, I mean to say. Confusing theory they know, right? Confusing theory. मतलब part of a whole they know, right? You can. Okay. A proper आप नहीं पता रहेगा, how can you solve big problem? That is the main thing. So via these gate crash course, you can learn, everything, okay, in next 4 to 5 sessions, right? So suppose there is a, situation is like odd plus even symmetric, right? So it will not exploit any symmetry, guys. No symmetry. Don't confuse, okay? Don't get confused, odd plus even will not give you any sort of symmetry, right? And suppose you are multiplying, odd into even, so you will get what? Even symmetry or odd symmetry. It will give you odd symmetry, sorry. Okay, if odd symmetry is there, right? So area under the odd symmetry will be what? Suppose inside the integration, suppose minus infinity to infinity, fx times gx is there, right? Dx. So suppose this kind of situation is there. It is even, it is odd. So answer will be 0, you can say, right? Answer is gonna be 0. Okay. If one of the signal is odd, one of the signal is even. Okay. So while solving the question, this will be very helpful, right? Now the question is, suppose any signal is given, right? Any signal you talk about, any general signal, right? You can say, right? So any signal xt may be expressed or can be expressed as sum of even symmetric part as well as the odd symmetric part. तो कोई भी signal दिया रहेगा आपके पास, right? तो अगर हम बात करते हैं how to compute even part and the odd part, okay? Even part and odd part of a signal. Okay, even part and odd part of the signal. You take any signal, you can write always any signal. You can say xt is given as, xt can be written as even part plus odd part of a signal. Xt is equal to even part of a signal xt and the odd part of a signal. Now, how to compute this x of t? So even part of xt can be computed. Remember, even part of xt can be computed, right? कैसे करोगे? Just take xt as it is, then find the folded version of xt. Find the folded version of xt and add with this and divide by 2, right? This is how you can do, okay? You can find out even part of the signal. So it is a two-step process. क्या करना है? xt is given, then you have to add, you have to just take the folded version of xt, then start adding, how to add to signal point wise. ठीक है, पॉइंट वाइज ऐड करना है, मतलब माइनस इन्फिनिटी से टी आ जाओ. कोई भी क्वेश्चन दिया रहता है तो आपको पहले ऐसे ही करना चाहिए, स्टार्ट फ्रॉम माइनस इन्फिनिटी टू दैट. Okay, point wise you just add it. Okay, now if you want to find odd part of xt, so in case of odd part of xt, what you have to do, you just take, okay, you just take xt as it is, then subtract x of folded version of that and then divide by 2. This will give you odd part. Now if you add these two, you are going to get what? Xt only, right? Xt. Okay. So this is very important to keep in mind. So xt, okay, you take just xt and forward xt, okay, to invoke so the symmetry, okay, like then you can invoke symmetry, right? So this is very important to keep in mind. Okay, understood. So how do we check whether xet plus xor of t is going to give xt? Just add them, right? That's it. Okay. Now the very important symmetry which will be very useful during Fourier series. Okay. So as I'm covering basics, so I'm going to cover basics for everything, right? So here the symmetry plays an important role. Symmetry not only plays an important role in signal and system, it plays important role everywhere. आप differential amplifier ले लो, right? You just take the differential amplifier, right? And you draw one line. So that will give you a symmetric circuit, right? Both transistors are symmetric, okay? Understood. And then what you can do, you just analyze half of the circuit. Rest half of the circuit is already analyzed, okay? So that is what the role of symmetry. So never take any question as difficult as it looks, okay? Always try to exploit some kind of situations, right? Whether any signal is any circuit or signal, whatever, you have to always go through the symmetry. So if any waveforms are given, life is very simple, okay? If any circuits are given, like while finding the R equivalents and all, right? Or while in future you will see very big circuits, right? But you have to exploit the symmetry. Yeah, fine. So this is the story that I have told you, right? Okay, now next is half wave symmetry, guys. Half wave symmetry, देखो नाम ही इसका ऐसा है, half wave symmetry. ठीक है? Okay, for half wave symmetry, always remember there should be on off pattern, on off, on off. If on off pattern is not given, then that cannot have any sort of on you can say half wave symmetry. कोई भी waveform दिया है, how to understand that this given waveform has got half wave symmetry, right? So you have to remember these points, whatever I'm going to tell you, right? So half wave symmetry is defined only for periodic signal. ये सबसे पहला आप notice कर लो, keep in mind that. ठीक है? सबसे पहले क्या है? SWS only defined okay, for only defined for periodic signal. If signal is not periodic, we never talk about half wave symmetry. ये भी एक सबसे important point है क्या? Half wave symmetry is only defined for it is never told anywhere. You can check out your notes. Just check out your notes. Nowhere is gonna be told by anybody that half wave symmetry is only defined for periodic signal. Okay, so this is very important. Okay, people talk half wave symmetry in case of Fourier series. Okay, so Fourier series is defined for periodic signals. So that is very important to keep in mind, right? Okay, if the value of the period, you can say you just take any periodic signal xpt, right? Okay, this is very important to keep in mind. Okay, so what you do here is you just take value of a periodic signal xpt, okay, with period t at t equal to alpha, you can say, and at t equal to alpha plus minus t by 2 now. Okay, so let me write here. Okay, so what is the definition here? Remember, always check the value of a periodic signal xpt, the value of periodic signal xpt, just like I told you in case of even symmetric and odd symmetric. आपको क्या देखना है? At minus alpha, at symmetric duration, you have to see what you have to see the amplitudes, right? The value of the signal, okay, at minus alpha, at alpha, अगर दोनों सेम है मतलब that is symmetric signal, right? और ऑड में क्या होता है? दोनों सेम होते हैं लेकिन 180 डिग्री का डिफरेंस रहेगा, माइनस का डिफरेंस रहेगा. ठीक है? इन केस ऑफ हाफ वेव सिमेट्री, if the value of, remember, if the value of what, if the value of a periodic signal, if the value of periodic signal xpt, okay, with period, you can say with period capital T, okay, okay, at, you have to see two values, at at what? At t equal to alpha, and at t equal to what? Alpha plus minus t by 2 or 0.5 by times t. You can say half a period away. Okay, half a period away. This is nothing but what? Half a period away. Okay, half a period away, differs only in sign. Kya? Differs only in sign. Differs only in sign. Right? Differs only in sign. Matlab, you can understand, right? The amplitude is gonna be same. The value is gonna be same. Okay. Okay, that you have to keep in mind. But the sign is going to differ, right? So that periodic signal is called as the half wave symmetric. Okay, that periodic signal is called as half wave symmetric. How do we show mathematically? How do we show mathematically? That is very important. So xpt, if xpt has half wave symmetric, okay, so you can say that this can be written as xp, okay, xpt, okay, plus minus t by 2. Okay. Or in general you can write, okay, because as long as the signal is periodic, right? So this can be in general written as minus xp t plus minus nt capital T plus minus nt capital T plus minus half capital T. Okay, so this is very important for integer and you can say for integer. So half wave symmetry कहाँ पर रहेगा? Always remember what is the definition of half wave symmetry. I told you कि if the value of a signal, okay, xpt, signal with you can say periodic period capital T at alpha t equal to alpha, and just take 2 instant of time, right? T equal to alpha and t equal to, you can say that half a period away, right? Half a period away, right? So that differs only in sign. Okay, that xpt is called half wave symmetry. Okay, so half wave symmetric signal always show 2 half cycles over a one period. ये बहुत important statement है that you have to remember always. In fact, let me cut this statement and paste for you, right? This is very important, right? क्योंकि आप लोग क्या होता है ना, सिग्नल कोई भी दिया रहेगा उसमें हाफ वेव सिमेट्रिक फाइंड करना चालू कर देते हो, राइट? यू हैव टू ऑलवेज कीप इन माइंड दिस. ओके, दिस स्टेटमेंट इज वेरी इंपॉर्टेंट. ओके, व्हाट इज दिस स्टेटमेंट? दिस स्टेटमेंट इज नथिंग बट हाफ वेव सिमेट्रिक सिग्नल. ओके, ये बहुत इंपॉर्टेंट है गाइस, तो आप याद रखना. जस्ट आई एम गोइंग टू पेस्ट हियर. ये बहुत इंपॉर्टेंट है. हाफ वेव सिमेट्रिक सिग्नल ऑलवेज शो व्हाट? 2 हाफ साइकिल ओवर 1 पीरियड. अगर कोई वेव फॉर्म दिया है in 1 period, if there are 2 half cycles, okay, if there are 2 half cycles, okay, so you can say that and then you check the what amplitudes, right? If they are also changing, you know, if they are differing by signs only but their amplitude is same, right? Okay, with each half cycle, remember next line, with each half cycle an inverted replica of other and the area of one period equal to 0. हाँ, तो एरिया अगर फाइंड करोगे, एरिया अंडर दैट पीरियड, वन पीरियड इज शुड बी इक्वल टू 0, राइट? So that is where the exploitation of what? That's where you can say that half wave symmetry will be there, right? It is very important concept. So I hope this makes sense to all. And let me take like, so you can remember this. You can also see this waveform along with the waveform. Okay, just I'm going to show you. So yeah, you see, this is a half wave symmetric, is defined only for periodic signal, and there are 2 half cycles per second per period. You can say each is inverted replica of other. You see here, okay. So suppose this from here to here, from here to here, it is like this. Now it is inverted of, it is, see, over one period. You see here it is, you can say negative -1, you can say that. Now it is +1 here. So for the half period, you see, for half period it is like this, and for half period just it has got inverted, right? So in this waveform there is a half wave symmetry. Sometimes what happens now, waveforms are given but they are shifted up and down, right? Shifted up and down, so you have to be very careful. You have to remove DC over there, right? If some waveforms are given, right, like in Fourier series, basically you have to look at half wave symmetry, right? It plays an important role for periodic signals, right? जैसा कि मैंने आपको बताया है, ठीक है? तो आपको क्या करना पड़ेगा हमेशा, if any waveform is given, so look at their amplitude levels, right? Whether they are shifted up and down. If they are symmetric, okay, they can differ by negative signs. Okay, yeah, it is needed also, right? Okay, for odd as well as for half wave symmetry, right? For odd signals also, the magnitudes, amplitude should be same, but they can differ by minus sign, right? In case of half wave also this is the property, but not in case of even, right? तो इसीलिए आप देखते होंगे कि whenever we talk about half wave symmetry, right, so there we always talk about कि odd harmonics are present, not even harmonics, right? So बहुत ही simple concept है, that concept you have to remember, right? So this is very important, guys, okay, that you can do. I'm not talking about any question. You can find questions and you can easily find out. Okay, this is important. Okay. Now there are harmonic signals and the sinusoids. Okay, harmonic signals are very important signals, guys. Harmonic signals are very important signals. Okay, harmonic signals means what? The signals, sinusoids. I think many of you might be familiar with sinusoids. Okay, sine omega t, cos omega t, right? Uh, why we talk about harmonic signals? Harmonic matlab what? Harmonic means suppose any frequency is given omega 1 and if another frequency is given omega 2, right? So two times of omega 1. So we call it omega 1 and omega 2 are harmonically related, right? Harmonically related. So sinusoids and you can say harmonic signals are one of the most useful periodic signals. Okay? They have very beautiful property also. So properties भी आपको याद रखना है. That property you have to always keep in mind, right? Okay, so any periodic signal you take like XPT, so periodic signals are also used in carrier as a carrier signals in communication system, right? In analog communication, right? So very important thing that you have to remember is what, suppose periodic signal is there. So what we are talking now is we are talking harmonic signals and sinusoids. Harmonic signals and sinusoids. ये टर्म्स को भी याद रखना जरूरी है, राइट? ओके, मतलब आप, आई होप दिस मेक्स सेंस, राइट? सो सपोज एनी सिग्नल इज गिवन दैट शुड बी पीरियोडिक, राइट? लाइक XPT, which is periodic signal, you can say that a cos 2 pi f naught t plus theta, right? So you see here, guys, here the frequency, here fundamental frequency you can say is f naught and it is a periodic signal. You can find out the time period as well, right? Okay, you can also write like this, xt is going to be equal to a e raised to power, right? E raised to power j 2 pi f naught t plus theta. This is also one way of writing, right? So if you take the real part of this, you will get this. Okay, because you know that according to the Euler's identity, right? Euler identity, what it says? Euler identity says that Euler identity, suppose you want to find xpt is equal to real part of what? Real part of this a times e raised to power j 2 pi f naught t plus theta, right? So these things are very useful while solving communication questions, or while solving in electromagnetic also. There is a concept of polarization. Okay, so there also we always take real part of something, right? So everywhere real part of something is computed, right? Okay, so taken care of, you can say, or considered. तो आपको कुछ ऐसा करना होता है, right? So real part of this guy is what? So real part of this guy, you can say, okay, so real part of this guy will be what? Okay, so you can write this as for complex exponential form requires two separate plots. Remember, it will be having real parts and the imaginary part. Okay, very important to keep in mind. Okay? So you can write this as what? 1 by 2, okay, a e raised to power j, right, 2 pi f naught t plus theta plus 1 by 2 a e raised to power minus j 2 pi f naught t plus theta, and this is nothing but what? A cosine 2 pi f naught t plus theta, right? ठीक है, आई होप दिस मेक सेंस. एंड इमेजिनरी पार्ट क्या हो जाएगा? माइनस साइन यहाँ रहेगा, दैट्स इट. ओके, एंड डिवाइड बाय जे. Fine. So Euler relation has got many forms, right? So one of the form is nothing but what? You can say that polar form, right? So here Euler relations you have to remember some form of the Euler relations. The first form is nothing but what? Suppose something is written like e raised to power plus minus j alpha, right? E raised to power plus minus j alpha, right? So you can write this as what? Cosine alpha plus minus j sine alpha. You can write like this, or you can also write this as what? 1 plus minus alpha, right? The magnitude is 1 and the angle is plus minus alpha. Okay, so these are the relation, you know, that you have to use while solving questions, right? So you should not get stuck anywhere, right? अगर इसका एप्लीकेशन आता है तो, और मान लो कोसाइन दिया है, कोसाइन ऑफ अल्फा. व्हाट इज कोसाइन अल्फा? दिस इज द रियल पार्ट ऑफ e raised to power j alpha. You can say that e raised to power j alpha plus e raised to power minus j alpha by 2. और तीसरा क्या होता है? तीसरा you can say that sine of alpha is e raised to power j alpha minus e raised to power minus j alpha by 2j. So these are the forms that also you have to remember, okay? Because in Fourier series, you know, we always compute Fourier coefficient. Suppose any spectrum is given, right? Fourier spectrum is given, Fourier spectrum, Fourier series coefficient spectrum. Now you have to find the Fourier series, right? You have to get back that summation, right? Xt equal to, you know, suppose any complex Fourier series you have to find out from the coefficient. So phase spectrum is given, the magnitude spectrum is given, right? And then you have to use these identities, okay, in order to get everything. Okay? So as I told you that you know, if there is a, you can say that suppose any periodic signal is given, right? Periodic signal xpt. Okay? So few things you have to remember here, right? So an analog harmonic signal is periodic for any choice of frequency. You can say any choice of frequency. You take any choice of frequency, right? But in case of discrete signal, you have to be little careful. Okay, in case of discrete signal, you have to be little careful. ठीक है? एनालॉग के केस में तो आप कोई भी साइनोसॉइडल गिवन है या इट इज अ पीरियोडिक, राइट? अगर वो सिंगल साइनोसॉइडल है, कॉम्बिनेशन इज डिफरेंट थिंग, राइट? कॉम्बिनेशन में फिर आपको रूल लगाना पड़ेगा. ठीक है, तो ये बहुत इंपॉर्टेंट है, राइट? तो मान लो कोई पीरियोडिक सिग्नल दिया है, इफ एनी periodic मतलब any analog harmonic signal is given that is periodic for any choice of frequency, right? So what are the things that you can talk about, right? So let me highlight this point also. Okay, see here you can talk about phase delay also. ठीक है, देखो, and analog harmonic signal is periodic for any choice of frequency, you say. Okay? But continuous harmonic signal, remember, in case of continuous, in case of discrete harmonics, right? Discrete की हम लोग बात करेंगे, discrete की. Okay, at that time, at that point of time, you have to be little careful, right? You have to test for periodicity, whether that is periodic or not. So xt is given as a cos 2 pi f naught t. You can also write omega naught t, okay, plus theta. So you can also write this as a cos omega naught t plus theta. You can also write this omega naught. Omega naught is nothing but what? Omega naught is nothing but 2 pi by capital T, right? Okay, these are the relation we use in case of electromagnetic also while computing, you know, the polarization and all, right? Type of polarization. A cos 2 pi t by capital T plus theta, right? Now what you can do here is you can take out, right? You know, 1 by t is nothing but f naught, right? You can say. So you just take out 2 pi f naught from here. So you will get t minus tp. What is this tp here? This tp is nothing but you can see here this, right? So frequency is omega naught is equal to 2 pi f naught. Okay, this omega naught is in radian, right? Radian per second, you can say. This is the time period 1 by f naught or 2 pi by omega naught, right? And the phase delay, right? Phase delay you can always find out. Okay. phase delay is going to be what? Which is denoted by TP. Okay, TP is nothing but the minus theta upon omega naught. Minus theta upon omega naught is called the phase delay. Okay, minus theta upon omega naught is called the phase delay. So I think this is clear for all, right? This you have to remember. And okay, so I'll talk about more concept in the next session, right? I'll talk about periodic, how to find periods of combination of signals, right? Suppose signals are given in combination, right? Like you have added many signals, right? X1t plus X2t plus X3t. How do we find out the fundamental time period? How do we find out the fundamental frequency? Okay, and so on and so forth. Certainly one or two questions can be there. And when you can say the signal is periodic, when you can say that the signal is not periodic, right? So those concepts we'll talk. Already we have discussed about the power of a periodic signal. Suppose combinations are given, right? Okay, like you can sum up sinusoids at different frequencies given. You can say x1 has omega 1, x2 has omega 2, right? So suppose any signal is given xt, which is xt equal to x1t plus x2t plus x3t and so on. So if you want to find the power, so power can be computed individually, right? Power of xt will be what? Px1 plus px2 plus px3. Provided all the signals should have different frequency. Matlab all the sinusoids, whatever you are adding, right? Whatever sinusoids you are adding, you can say sine plus cos. So all guys should have different frequency. ठीक है, ये कंडीशंस हैं. आप कंफ्यूज हो जाते हो जब आपको आरएमएस वैल्यू निकालना होता है या कि पावर निकालना होता है, राइट? तो ये सारी चीजें याद रखना. तो हम नेक्स्ट क्लास में बताएंगे, क्वेश्चन भी कुछ सॉल्व करेंगे, राइट, बेस्ड ऑन दैट. उसके बाद हम लोग बात करेंगे कॉमनली एनकाउंटर्ड सिग्नल्स, राइट? तो कॉमन, ये सेकंड क्लास था. थर्ड क्लास में ये सारी चीजें होंगी, कॉमनली एनकाउंटर्ड सिग्नल्स, राइट? विल टॉक अबाउट यूनिट रैम्प, यूनिट स्टेप रैम्प, signum functions, okay, all these things. And then we'll talk about various property, like we'll talk about impulse functions, okay. So your chapter 1 will be over, right? Then discrete signal will come. So I think next session I might start discrete also, discrete signals. Then we will start system, and then we'll talk about Fourier series, Fourier transform, Laplace transform, G transform. So once the basic is over, I will not take much time, right, to explain, because but in transforms theory, basically what is there, definition is there, property is there, that's it. Okay, then we have to start from 1st December, the PYQ, right, previous question paper. We'll meet in the next session. Thank you so much, guys.